Hello 11th class science aspirants. Hope you are in good health and spirits. Myself Dr. Amritpal Singh and you are watching Science for Aspirants YouTube channel. So as you all know that we are discussing 11th class physics and we are talking about chapter number 1, that is units and measurements. In our previous lecture we have talked about the significant figures and the order of magnitude, and then we have discussed about some important numerical problems. In our today's lecture number 3 we will discuss about the dimensional analysis, how we can derive these dimensional analysis equation and what are the uses of these dimensional analysis, and then we will talk about the principle of homogeneity, and then we will do some numerical problems which are came in previous year JEE or NEET examination. So let us start our lecture. So starting with the uses of dimensional analysis. Now why we use these dimensional analysis equation? Now there are 4 important uses of these dimensional equations. So first is this method of dimensional analysis, it check the correctness of the equation. ਹੁਣ ਜੇ ਸਾਨੂੰ ਕੋਈ ਇਕੁਏਸ਼ਨ ਦਿੱਤੀ ਹੋਈ ਹੈ, ਸੋ ਜੇ ਆਪਾਂ ਚੈੱਕ ਕਰਨੀ ਹੈ whether that equation is right or wrong, and we can check that equation by finding the dimensions of that equation. So second use is derivation of the relation between the physical quantities involved in any phenomena. So we can derive any physical relation, or we can derive the correct physical relation. So for example, if it is given that the force, it is dependent upon mass, length and time, and from these physical quantities we can derive the correct relation of this force with these physical parameters. So third property is finding the dimensions of constants or variables in an equation, and we can find out using the dimensional analysis method the dimensions of the constant and what are the variables which have been used in this equation. And fourth part is we can convert from one system of unit to another system of unit. So for example, if the force, it is given in SI unit, and from that method of dimensional analysis we can convert the force in CGS system of unit, that is in dyne. So how we can use this method of dimensional analysis? So before doing some methods with the help of numerical problems, so let us discuss the principle of homogeneity of this dimension. Now there is a beautiful example which is shown to your screen. Now let us consider a simple equation that is equal to a plus b, which is equal to c. Now if this is an equation of physics, then a, b and c, they are the physical quantities, and this equation says that one physical quantity a, when added to another physical quantity b, it gives a third physical quantity that is equal to c. So this equation will have no meaning in physics if the nature of the quantities or the dimensions of the quantities on the left hand side of the equation is not the same as the nature of quantities on the right hand side of this equation. So what does it mean? So this equation, it will have some valid parameters, or this equation is valid only when if the left hand side of this equation that satisfies equal to the dimensions of right hand side of this equation. So for example, if a is the unit of length and b must also be a unit of length, so when we add these two parameters, so they should be equal to the same units, and the result of addition of a and b, it should also have the unit of length. So in other words, so the dimension of both sides of physical equation, so they must be same. So this equation is called the principle of homogeneity of dimension, and using this principle of homogeneity of dimensions we can convert one system of unit to another system of unit, or we can derive any dimensions of any given equation. So let us do some numerical problems related to this Principle of homogeneity. So first example is the distance x traveled by a body varies with time, and this equation is given x is equal to at plus bt square, where a and b they are constants. So we have to find the dimensions of constants a and b. Now we know that the dimensions of each term on the right hand side of the given equation, it must be equal to the left hand side of this equation. So left hand side dimension, it should be equal to right hand side dimension. So when I equate these, so you can say that dimensions of AT so that is this, it should be equal to dimensions of x. And what is this x? X is distance and t is time. So from that, equating these two parameters, from that we can find the dimensions of a, that will be equal to dimensions of x over dimensions of t. Now x is distance and dimension of distance is length L, and dimensions of time is t. So dimensions of a, it comes out to be equal to L t raised to power minus 1. So in this dimension equations, we generally compare with the three parameters, that is equal to m, L and t. So we can write this equation as m raised to power 0, L raised to power 1, t raised to power minus 1. So similarly we can find the dimension of constant b. So when we equate this dimension of bt square, so that should be equal to again the dimensions of x. So b is a constant, and from that it will be equal to x over t square. So x is having a dimension of L and t is having a dimension of t square. So dimension of constant b, it comes out to be equal to L t raised to power minus of 2. So this is our result. So we have found the dimensions of a and b. So we can also write the dimension of b as m raised to power 0, L raised to power 1, t raised to power minus of 2. So this is our answer. So using this principle of homogeneity, you can derive the dimension of any constant value. So next example is the pressure P, volume V and temperature T of a gas. They are related with this equation, and here A, B and C, they are constant. So this is small a, small b and small c. So they are constants. So from this above equation, we have to find the dimensions of constant a over constant b. Now using the principle of homogeneity, we know that dimensions of a over v square, so that should be equal to dimensions of P, because this is again the sum of these two equations, so their dimension should be equal, so they should be identical, and from that dimensions of A, so that will be equal to dimensions of P into V square. So similarly we can find the dimensions of constant b, so that will be equal to dimensions of v. So from this v minus b equation, so putting the value of this dimension of a and b, so when we divide these dimensions of a over b, that will be equal to dimension of pv square over dimensions of v. So what does it mean? So that is equal to dimensions of P into V. Now putting the value of this dimension, where P is pressure, Pressure we know that is equal to force per unit area. Force dimension is ml t raised to power minus t square, that is equal to m into a, and area is L square, and from that the dimension of pressure is ml raised to power minus 1 t raised to power minus 2, and volume that is equal to length cube. So volume of cube that is equal to length into breadth into height, and that is equal to L cube. So putting the value of this dimension of P and V, so which is m L raised to power minus 1 t raised to power minus 2 into L raised to power of 3. So in this, so our result, it comes out to be equal to ml square t raised to power minus of 2. So the dimensions of A over B, that will be equal to ml square t raised to power minus of 2. So this is our answer. Moving towards the next question. So next question is, when a plane wave travels in a medium, the displacement y of particle located at x distance at time t is given as. So we have given a relation of sine wave. So here y is the displacement. So y is equal to a is the amplitude of the wave. So that is equal to sine bt plus c of x. Now this is sine theta. So ਜੇ ਆਪਾਂ simple sine wave ਦੀ ਗੱਲ ਕਰੀਏ, that is equal to amplitude a sine of theta. So we know that ਹੁਣ theta ਜਿਹੜਾ ਹੈ, so that is a dimensionless parameter. So from this, the value of this bt plus cx or bt and cx, so they must be dimensionless, because theta, it is a dimensionless parameter. So bt and cx, they must be dimensionless. So bt, so any dimensionless parameter, so it is having a constant, so that is considered as a constant value which is equal to 1, and from that the dimension of b, that will be equal to 1 over t, and t is time, and time has dimension of 1 over t. So from this dimension of b, it comes out to be equal to t raised to power minus 1. So similarly you can find out the dimension of constant c, and so c comes out to be equal to 1 over x. So x is a distance, so distance has a dimension of L, so it comes out to be equal to L raised to power minus of 1. So putting the value of this b, dimension of b over c, so dimension of b is t raised to power minus 1 and c is L raised to power minus 1. So this comes out to be equal to L t raised to power minus of 1. So this is our answer. So moving towards the next question. So in the given expression, P is equal to a square over b exponential of minus ax. Here P is pressure, x is distance, a and b are constants. So from this we have to find the dimensional formula over b. Now exponential term, it is a dimensionless parameter. So if this is a dimensionless parameter, so what does it mean? So it means that the dimension of pressure, it should be equal to dimension of a square over b. Here a and b, they are constants, and from this we can find the dimensions of b, that will be equal to dimension of a square over dimension of pressure P. So putting the value of a square, so a, so how we can find the value of this dimension of a square? Now exponential of minus of ax, so that is a dimensionless parameter. So what does it mean? It means that ax, this term is equal to 1, and from that we can find the dimension of A, that will be equal to 1 over x, so that is equal to L raised to power of minus 1. So from this, when we put the value of this A in this equation, so A square will be equal to L raised to power of minus 2, and pressure, that is equal to force per unit area whose dimension is ml raised to power minus 1 t raised to power of minus 2, and from this we can find the dimension of B, that is equal to, when they move upward, so m becomes m minus 1 L raised to power of minus 1 t raised to power of 2. So this will be the dimension of constant B. So this is our answer. So moving towards the next question, the time period of a simple pendulum may depend upon m, that is the mass of bob, it depends upon the length L of the string, and g, that is the acceleration due to gravity. So from this we have to derive a relation among these parameters कि सानू इन्हां दे विच जिहड़ा रिलेशन है वो ड्राइव करना पएगा। हुण सानू दिता की है, सानू दिता है कि टाइम पीरियड जिहड़ा है it is dependent upon mass of the bob. So let us say m raised to power of a, it is dependent upon length, let us say it is dependent upon parameter b, and it is dependent upon acceleration due to gravity, that is any relation constant c. When we open this direct relation, so this will be equal to k, where k is any dimensionless constant. So m raised to power of a, L raised to power of b, and g raised to power of c. Now writing the dimensions of each quantity here, time period, so it has a dimension of t, so that will be equal to, so k is a dimensionless constant, so ਇਹਦਾ कोई dimension नहीं होएगा, where m is mass of this bob, so mass has dimension of capital M raised to power of a, L is the length of the bob, so that is L raised to power of b, and g, that is acceleration due to gravity, so who has a dimension of L t raised to power of minus 2 raised to power of c. Now on the left hand side we have to rewrite this term in these three physical dimension parameters m, L and t. So we can write the left hand side as m raised to power of 0, L raised to power of 0, and t raised to power of 1, that is equal to m raised to power of a, L here L raised to power of b, and here it is L raised to power of c. So we can write it as L raised to power of b plus c, and t raised to power of minus c. Now using the principle of homogeneity of dimensions, the dimensions of all the terms on either side, so they must be equal to all the terms on right hand side. So equating the power of these m, L and t, now when we equate these power on the left hand side, so m has a power of 0, here m has a power of a. So what does it mean? It means that a will be equal to 0. So again equating the power of these L, so here on the left hand side L has a power of 0, while on the right hand side it is equal to b plus c. So what does it mean? It means that b plus c is equal to 0, therefore b is equal to minus of c. So third, equating the power of this t, so t is equal to 1 on the one hand side, left hand side, so that is equal to minus of 2c. So what does it mean? 1, that is equal to minus of 2c, and from that c will be equal to minus 1 by 2. So putting the value of c in this equation, so minus of minus 1 by 2, so b comes out to be equal to 1 by 2. So we know all these parameters, that is a is equal to 0, b is equal to 1 by 2, and C is equal to minus 1 by 2. So putting these values in this equation, so T that is equal to K m raised to power of A is 0, L raised to power of B, so B is equal to 1 by 2, and G is power of C, so C is equal to minus 1 by 2. So from this we can derive the relation, so T is equal to K under root of L over G. That is the time period of simple pendulum. It is independent of the mass of the bob, because here there is no any mass term which comes in this relation, and this time period, it is dependent upon the length of this string, that is directly proportional to under root of L, and it is inversely proportional to under root of G. So this is how you can derive any physical relation using this dimensional analysis and the principle of homogeneity. I hope you have understand this method. So let us do one more numerical problem. So next question is, dyne is the unit of a force in the CGS system and Newton is the unit of force in SI system. So how we can convert one dyne into 1 Newton? Now we know the dimensional formula of a force. So force is equal to mass into acceleration. So its dimensional formula is mLt raised to power of minus 2. So using the equation, that is equal to n1 u1 that is equal to n2 u2. So here if we are talking about the units in system 1, so it should be equal to the dimension, so they should be equal to dimension in system 2. So let us say our system 1, that is the given system, that is the CGS system, and this is our SI system. So here n1 that is equal to 1 dyne, it is given, and UI parameter that is dependent upon these 3 parameter, which is M, L and T, and force, it is dependent upon all these 3 parameter. So from this equation, so therefore mass in CGS system that is equal to grams, length in CGS system that is equal to centimeter, and the time period in CGS system that is equal to 1 second. And similarly if we talk about the SI system, so N2, this we have to find the value, how much it will be equal to number of newtons, and the mass M2 in SI system we take it in kilograms, so length we take it in meters, and the time period in SI system is that is equal to second. So equating this equation on left hand side of one system to right hand side of another system, so N1 of U1, so U1 is dependent upon M1 of A into L1 of B into T1 of C. So what is the value of here A? So A is equal to 1, B is equal to 1 and C is equal to minus of 2. So we can equate that is equal to N2, which is equal to M2 raised to power A, L2 raised to power B and T2 raised to power C. So we have to find the value of N2, that will be equal to N1 into M1 over M2 raised to power of A into L1 over L2 raised to power of B into T1 over T2 raised to power of C. So putting the value of this A, B and C, so N2 that will be equal to N1, here N1 is equal to 1 dyne into mass in first representing mass in CGS system, so that is equal to 1 gram over mass 1 kg, that is equal to 1000 gram raised to power of 1. So L1, that is length in CGS system, that is equal to 1 centimeter, and length in meter, so 1 meter is equal to 100 centimeter raised to power of B. So again B is 1, so we can write it here 1, and T1 time is 1 second over 1 second raised to power of C. So they get cancelled out. So what we are left with is, so 1 gram over 1000 gram, so that is equal to 1 gram over 10 is to power of 3 gram into 1 centimeter over 10 is to power 2 centimeter. So in the denominator, so here N2, that is equal to 10 is to power of minus 5. So what does it mean? So it means that that is equal to 1 into 10 is to power minus 5 newtons. So from here we can write down that 1 dyne, that is equal to 10 is to power of minus 5 newton. So this is how using the principle of homogeneity and the dimensional analysis formula you can convert one system of unit into another system of unit. I hope कि ਤੁਹਾਨੂੰ ਜਿਹੜਾ ਅੱਜ ਦਾ ਲੈਕਚਰ ਹੈ ਉਹ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ. So if you have any doubt in any question you can write in the comment box. ਸੋ ਇਸੇ ਤਰ੍ਹਾਂ ਦੇ ਹੋਰ JEE ਔਰ ਨੀਟ ਦੇ ਐਗਜ਼ਾਮ ਦੇ ਰਿਲੇਟਡ ਕੁਐਸਚਨਸ ਨੂੰ ਜਾਣਨ ਦੇ ਲਈ ਯੂ ਕੈਨ join or subscribe our channel. So see you in the next lecture with more some exciting questions. Till then, goodbye, stay safe, stay healthy.